Good evening, friend. I'm glad you're here, where the lights are low and time feels unhurried. Perhaps your shoulders are already settling, your jaw remembering ease, and each breath arriving like a small, quiet wave touching an easy shore. You are safe, and there is nothing you need to do. Tonight, we'll drift beyond the crowded cities of stars to a hush so deep it seems to hold its own kind of music. A vast, dim, hollow in space, sometimes called the Boötes Void, the largest known emptiness in the observable universe. Think of it as a great, velvet room between galaxies, where distance unfolds like a long hallway and silence becomes gentle company. As your body grows heavier and your thoughts grow light, we'll explore how such a quiet place can exist, what it tells us about the way matter gathers and leaves room for wonder, and why that calm, star-poor expanse can feel strangely comforting. If this gentle journey helps you rest, a quiet like and subscribe helps other sleepy travelers find their way here too. For now, close your eyes if you wish, and let the night carry you. Let's begin. Far out in Boötes, there is a hush so wide that even starlight seems to pause for breath. Not the ordinary spaces between stars, not even the long reaches between neighboring galaxies, but a broader clearing where galaxies themselves are scarce. A great, dim meadow in the cosmic night. Astronomers call it the Boötes Void, and the scale of it is gentle and overwhelming at once. Picture light, swift as anything we know, setting out across that quiet and traveling for hundreds of millions of years before it reaches the other side. In the mind's eye, it feels like a lake without shores, smooth as glass beneath moonlight, a place where sound would have nowhere to echo, and therefore no need to be loud. The story of its discovery reads like a simple moment of listening. In the late 1970 seconds, Robert Kirshner and colleagues were mapping galaxy positions the way one might trace the lights of distant towns on a winter road. Point by point, the sky offered clusters and strands, a luminous cartography. Then the pattern thinned. Where there should have been city after city of stars, there was almost nothing. Instead of a sprinkled archipelago, they found a dark plain, a patch as bare as a field after snow has covered every footprint. The surprise was not a shout, but a held breath. Models of the time pictured a universe that looked broadly similar in any direction, busy with galaxies, mostly uniform, like the view of America at night from high above, dotted and connected. Yet this place in Boötes was different in a way that wasn't easy to explain, and the difference tugged gently at the sleeve of understanding. Scale is slippery at night, but the mind appreciates comparisons. Imagine the Milky Way as a small coin, cool and circular in the palm. Now lay that coin down in a room so large you could scatter thousands more and still see floor between them. The void stretches roughly 330 million light-years across a reach so broad that even metaphors want to sit down and rest. It is not an angry absence. It is more like a quiet room in a large house, the door slightly open, the corridor dim, the clock in no hurry. The very existence of such a room changed the conversation about how the universe arranges itself. Listening more closely, astronomers began to notice a grander pattern everywhere, a cosmic web. Galaxies gather along threads and sheets, the way dew beads along the strands of a spider's web at dawn. Between those bright strands lie open spaces, voids, places where matter is thinner and galaxies are few. Boötes is among the largest of these clearings, and for a while, early maps showed only a handful of tiny lights in all that dark. Later surveys, deeper and more patient, found more than a few, but still far fewer than a naive sprinkling would predict. The impression remained. Here, the universe has chosen spaciousness, and the lights are polite and widely spaced. To live here as a galaxy is to learn a different kind of neighborhood. In busy regions, galaxies wander in company. They tug on one another, swap gas like quiet merchants, collide and merge and light up new stars in a steady hum of activity. In a void, the distances stretch. The nearest neighbor might be tens of millions of light years away, like seeing a porch light on a far hill and knowing there is kindness there, but not a quick path to reach it. The Andromeda Galaxy sits about 2.5 million light years from the Milky Way. A void galaxy might wait 20 times that far for a close companion. Isolation is not sorrow, it is a different rhythm. Star birth slows. Heavy elements, those forged in generations of stars and traded during encounters, accumulate more slowly. The galaxies look a little smaller, a little paler, as if the quiet around them has taught them to speak softly. Astronomers have a tidy term, underdensity, for this broad quiet. But the word misses the texture. It's like calling the night under bright. What matters to the heart is the feeling, a space where the mind can walk without bumping its elbows, where a single breath seems to reach farther. Even so, science keeps kindly asking, how did such a large quiet arise? The early universe began with small ripples in density, slight thickenings and thinnings in the primordial soup. Over time, gravity coaxed matter toward the thickenings, drawing filaments and clusters, while the thinnings, these voids, relaxed and widened. Emptiness, once it starts, has a way of making room for more emptiness, the way a slow stream carves a wider channel without having to hurry. Matter tends to flow toward where there is more of it, and in doing so leaves the low places gentler and broader. Inside Boötes, the few resident galaxies appear to trace a faint path, as if following a thread you can feel more than see. In some maps, the arrangement looks like a soft, invisible corridor stations along a long, quiet line. It is tempting to imagine an ancient filament of unseen matter, dark matter, the transparent scaffolding of the cosmos lingering there, a ghostly guideline left over from earlier times. The galaxies seem to follow that suggestion, not in lockstep, not like beads on a perfect string, but in the way fireflies might hint at where a stream runs through the dusk. From one vantage, the line looks thin. From another, it collapses to a single dot of gathered light. Perspective in the universe has its own little games. This picture softens when you let it. The thread is not certainty, but memory. The early universe, cooler and simpler, laying down the first drafts of where matter would pool and where it would part. Over billions of years, as gravity stitched the bright web, the quiet between the stitches stretched. The remaining galaxies in the void kept to whatever scaffolding remained, flowing along an invisible slope, their motions gently in the same general direction, like leaves caught in a slow current whisper of influences we cannot directly see. Not a conspiracy, just the silent grammar of gravity at work in a roomy sentence. The numbers, even softened, are still awe. Distances between neighbors measured in tens of millions of light years, metal content lower than similarly aged galaxies elsewhere, star formation not absent, only relaxed. It is a cosmic countryside without many crossroads, a place where seasons change but the town remains small. In regions packed with galaxies, encounters stir gas into fireworks. In a void, gas stays more diffuse. There are fewer nudges to spark a blaze. Stars are born, yes, but with the steadiness of a hearth that never roars. As for growth, voids do something that feels, at first, like a riddle. While the whole universe expands, space itself lengthening like a slow exhale, the emptier regions effectively open faster, not because they push, but because matter elsewhere pulls more strongly. Think of a quiet bay connected to the sea by a narrow channel. Water slips out toward the deep where the tide is rising, and the bay lowers without any wind at all. In cosmology's patient math, that means the boundaries of a void sharpen and drift outward over time. The bright filaments encircling a void become busier, and the clearing within grows a little broader, century by soft century, epoch by unhurried epoch. This is not instability in the alarming sense, not a tear in the fabric, so much as the fabric finding its drape. Gravity gathers, expansion stretches. Between those two motions, a pattern appears: webs and rooms, avenues and courtyards, bright knots and restful hollows. Boötes is a courtyard large enough to make the steps echo. Its edges host busier streets. Its interior keeps the calm. There is comfort in realizing that quiet has structure. The universe is not a uniform blaze, but a balance of blazing and breathing. Where matter clusters, we get the drama, collisions, births, the crowded marketplaces of stars. Where matter thins, we get a contemplative space, fewer transactions, more sky between the lamps. The galaxies that live there carry that mood in their spectra and shapes, in their slow-made elements and unhurried stars. They are not broken, only adapted, like desert plants that bloom rarely and brilliantly when the rain does come. Return to the image of coins on the floor and soften it. Not a floor to fill, but a floor to notice. You could set down thousands of bright disks and still find long reaches of bare surface, and that bareness is part of the pattern that lets you see the coins at all. Or think of a winter orchard. Under a pale moon, the trunks spaced far apart, the snow lying cleanly between them. The space is not wasted. It is what lets each tree be seen as itself. The night loves perspective, so let's hold two truths at once. On human scales, emptiness can feel like absence. On cosmic scales, emptiness is permission. The Boötes Void gives the web its shape, the way the holes in lace make the pattern visible. A few quiet galaxies move through it like lanterns carried on a long walk. They are far from neighbors, but not from law. The same gravity that gathers clusters is the gravity that keeps a gentle order here. And the same expansion that separates things with time gives us the chance, right now, to look across a gulf and trace a line of light. Some early maps counted only 8 tiny islands in that sea and wondered at how few there were. Later, with more patient listening, astronomers found more still, not the thousands a uniform sprinkling would suggest, but enough to sketch a path. The count matters less than the feeling. This is a room set aside, a place where the universe seems to practice the art of spaciousness. When the surveys deepen again, the story will refine the way stories do, adding detail without erasing the hush at the center. Let the mind stand in that room a moment longer. The walls are far away, the air is cool. On one side, beyond the quiet, the bright filaments bustle like streets near a harbor. On the other, the dark opens into more dark, and there is a sense not of threat but of endlessness without edges. Somewhere in that distance, a small galaxy turns slowly, nursing a few new stars. Its nearest companion glows faintly across a gulf, too far for conversation, close enough for company. The two have time, and the space between them is not a mistake. It is how the universe breathes. Out, near the quiet center of that clearing, the few resident galaxies continue their slow separation, like lanterns drifting to the far sides of a wide, dark lake. Distance lengthens without hurry. The spaces between them grow almost imperceptibly with each passing million years, and yet the trend is steady enough to feel like a tide. What complicates the picture is the hint that this widening isn't merely the universal exhale that carries everything apart. In the equations, flows out of underdense regions look a little stronger, as if emptiness itself were a gentle slope down which matter glides. Some treat that slope as an effective push and give it a name that sounds like weather, a wind from the void, though the air here is mathematics and the motion is patience. The mind of physics keeps a small shelf for bolder possibilities. On that shelf sits a polished thought experiment. Perhaps a patch of space can find itself in a slightly different vacuum state, the way water sometimes supercools and waits for a seed of ice. In such a false vacuum, the rules would be almost the same, but not quite. The pressure would be strange, the expansion eager, and the boundary would nudge ordinary matter away. It's a working theory, a lantern held out over a path we cannot yet see, and most evidence favors a simpler reading. Dark energy, insofar as we can tell, behaves like a uniform mist, not a puddle that pools in special places. Still, late at night, theory likes to wonder, if a region did lean toward an unusually expansive mood, light inside it would stretch a bit extra on its way to us, reddening just enough to make distant pinpricks seem farther and fainter than their true address. Observers do find small additional redshifts associated with the slow outward flow from voids. The numbers are modest, but the feeling is real, like a quiet echo hidden under the main song of cosmic expansion. At the edges, the mood changes. The boundary of Boötes gathers into crowded filaments and sheets, many times busier than the broad interior. Picture a coastline where the open sea meets a line of lit harbors. Along those bright margins, galaxies stack and weave into long curtains. Some stretches carry tens of thousands of islands of light, the way a dense archipelago marks the edge of a continent. Across a relatively narrow band, narrow only by cosmic standards, the scene shifts from bustle to hush. One side offers the familiar chatter of galaxies in company. Just beyond, the lamps thin quickly, and then there is mostly night. Maps trace this transition with a clarity that feels like a cliff. Gravity typically smooths, changes into gentle slopes. The sharpness here invites the question of what sculpted so clean a face. Motion along the walls adds another clue. Galaxies threaded through those luminous draperies show peculiar velocities, a subtle leaning away from the empty center, as if the whole curtain were being drawn taut. In the language of cosmology, it looks like a gradient of pressure, the effective push, again, though beneath the metaphor lies a more ordinary tale. Matter flows from where matter is scarce toward where it is plentiful, and the geometry near a deep hollow can amplify that stream. Simulations manage to reproduce voids and walls, the web and its courtyards, yet sharpening a wall to the extremes. Some surveys hint at remains a craft that challenges even the latest models. That tension isn't failure. It's a chalk mark on the blackboard, a place for next ideas to begin. Light, faithful messenger that it is, tells us about these borders by bending ever so slightly as it passes. In dense walls, gravity focuses beams by a hair's breadth, distorting the shapes of background galaxies the way a window pane sometimes ripples a view. Across the empty interior, the effect reverses. Underdensities act like a lens of the opposite sign, letting light diverge a touch, so that, faraway smudges appear a little smaller and dimmer than they would through a perfectly average universe. No carnival mirrors, just the gentlest persuasion, measured in fractions and carefully teased out of noisy skies. Even that faint signal is a kind of fingerprint. The void not only lacks matter, it leaves a mark on the paths that pass through. Every so often, a group of galaxies wanders close to the boundary and begins to feel the stretch. Tides are not only ocean stories, they are gravity's patience writ large. A small group near a massive sheet can be pulled into an elongated shape, its gas drawn thin on the side that leans into the flow. Star formation can tilt from steady embers to odd, asymmetric flares, as if the hearth were being coaxed and tugged by an unseen hand. Nothing monstrous, just the cumulative effect of long, slow forces across long, slow time. Wind the clock far back, and the picture softens into first principles. The infant universe carried tiny differences, thickenings and thinnings in its earliest light, imprinted by quantum jitters and smoothed by the great early swelling we call inflation. Gravity gathered matter toward the thickenings, threading the web. The thinnings, given time, relaxed into broader clears. In that sense, Boötes is a natural child of initial conditions. Yet its sheer size and clarity tempt the thought that the seed under density here was especially deep or especially well placed. Some models stack the dice slightly by altering how the early expansion amplified certain ripples, producing bigger courtyards and brighter knots than a pure coin toss would yield. Others note that if, for whatever reason, dark matter's invisible scaffolding was sparse in this region, the usual ladders for gas to climb and condense into galaxies would have been missing from the start. With fewer footholds, the emptiness would have had permission to persist. The metaphor of hills and valleys, so common in physics, remains helpful at night. In the crowded districts of the cosmos, space-time dips slightly under the weight of mass, like a slow, deep breath that holds a tone. Inside a great hollow, the dip is shallower. The geometry resembles a saddle curved one way, eased the other, so that light slides out in paths that separate more than they would through denser lands. General relativity predicts another quiet consequence. Where gravity is weaker, time passes a shade faster. A clock carried through the void would tick ahead by a few parts per billion, compared to its twin, resting by a rich cluster. It's not a difference anyone would notice over dinner. It's a whisper only precise instruments can hear. Still, it is there, a tiny labor of love from the way geometry meets existence. Even ripples in space-time, the gravitational waves launched by distant dances of black holes and neutron stars, carry the signature of open country when they cross it. Models suggest their crests stretch and their amplitudes shift by amounts so modest that only the next generations of instruments might collect them. If those measurements arrive, they will sketch voids in 3 dimensions, not with light, but with the music of the universe itself, drawing maps from the faintest changes in rhythm. The ancient light that bathes the whole sky, the cosmic microwave background, also keeps a ledger of crossings. As those photons traverse vast hollows and highlands, they gain and lose tiny amounts of energy from the changing gravitational scenery, arriving a touch cooler or warmer than they would have otherwise. These small imprints do not shout the name of any one void. They speak, instead of populations, the general habit of emptiness and structure to leave fingerprints on the earliest light. Analysts debate and refine, stacking maps upon maps to sift signal from static. Whatever else the arguments yield, they support the larger truth. The cosmos learned its pattern early, and has been elaborating it ever since. Talk returns, as it often does, to dark energy, the gentle, stubborn pressure that makes expansion accelerate. The simplest picture paints it as a uniform property of space, the same everywhere, like a thin, even mist. That view fits the broadest swath of data, and it comes with a quiet grace. The large-scale universe looks the same in every direction because the rules don't play favorites. Yet theory, forever curious, explores side paths, fields that fluctuate, energies that couple to matter in ways too delicate for current instruments, or rare pockets where the vacuum might briefly prefer an alternative state. These are sketches, not portraits. They give us ways to ask better questions when tomorrow's telescopes and detectors tilt their faces to the sky. Meanwhile, the everyday life of a void continues. Matter pours outward along the easiest routes, like groundwater finding the river. The bright walls grow busier as they drink in that flow. The clearing broadens so subtly that even 1,000,000 years is barely a heartbeat. Over billions, the room becomes larger and quieter still. Within, a few galaxies tilt along their faint corridor, chemistry unfolding at a relaxed pace. Their spectra show fewer heavy elements. Their star nurseries flicker with less haste. Their shapes tell stories of a life with little interruption. Not deprivation, just a different curriculum, where patience is the main instructor. One can step back from the chalkboard and notice the poetry. The universe composes itself not only with notes, but with rests. The webs, those long phrases of clustered light, carry the melody. The voids provide the breath marks that make the melodies singable. The boundary of Boötes is a bar line, crisp and striking. Inside, a whole measure of quiet. Across that staff, faint lines, gravitational, luminous, keep time. A photon leaves a wall, walks the long aisle, and exits the far side with its color stretched a hint more red. A small group approaches the margin, feels the tide, and elongates like a comet of stars. A pulse of space-time sweeps through and changes key by a fraction so small it takes deep listening to hear. To call this a battle between matter and emptiness is to add drama where there is already enough wonder. The walls are not barricades so much as shores, continually reshaped by the slow exchange between sea and land. The emptiness is not a predator. It is the absence that lets everything else be seen. If the Boötes courtyard grows larger with time, that growth honors the same two forces at work everywhere: gravity that gathers, expansion that loosens. Between them, structure appears, the familiar lace of the cosmic web, its beauty woven as much from what is missing as from what shines. The oldest light in the universe hums softly across the sky, a faint afterglow from when the cosmos was young and newly transparent. It is almost perfectly even, like a lullaby played on a single, steady note, with only tiny ripples, minute warm and cool shadings that whisper where matter was a touch thicker or thinner in that first clear dawn. Along the direction of Boötes, that glow carries a subtle coolness, a shadow only a few dozen millionths of a degree, spread over several degrees of sky, small in temperature, wide in reach. Like the trace of a passing cloud, you feel more than see. This cool patch tells a long story about an emptiness that has been finding its shape since the universe was only 380,000 years old. Light that old is honest, but it is not indifferent to the road. As it threads the cosmic web, it passes through regions where gravity's wells and hills slowly change. When a photon falls into a gravitational hollow and climbs out again, if that hollow shallows with time, As happens in a universe whose expansion is gently accelerating, the climb costs a little extra. The photon emerges slightly poorer in energy, stretched toward redder color, cooler by a whisper. This quiet transaction is called the integrated Sachs-Wolf effect, a name as technical as a filing cabinet. The feeling of it is simpler. The light pays a toll to cross evolving landscapes. An underdense region like the Boötes clearing has been relaxing for billions of years, and the CMB photons that traverse it carry that history, their tone lowered by the long crossing. From the depth and breadth of the cool patch, models can sketch the void's past in soft pencil. Start with a modest underdensity in the early cosmos, and let gravity and expansion work their patient weave. The clearing widens, the edges sharpen, and the imprint on the ancient light deepens accordingly. Yet when the pencil meets the data, something gentle but interesting happens. The observed coolness is weaker than many simple models expect, roughly half the amplitude that naive calculations predict. The cosmos often keeps its edges rounded. Perhaps foreground gas along the path added a faint warmth back into the beam, or small-scale motions and patchy reionization stirred the signal in ways that soften its contrast. The discrepancy is not a scold, it's an invitation, evidence that our picture of how emptiness evolves still has brushstrokes to add. The shape of the cool patch tells its own quiet geometry lesson. Its angular size and the way the temperature dips across different directions suggest we are looking almost straight into the hollow, seeing close to its full cross-section. Face on, not edge on. A window, not a thin crack. Other voids make their own delicate signatures in the microwave background, but few are as broad or as clean to read. Together, these faint, cooler stains help tune the larger score, offering independent hints about dark energy's steady hand and the way early inflation set the first scaffold of ripples. Even whispers, when heard across the whole sky, help keep time. When astronomers map the Boötes clearing in detail with galaxy surveys, patient pointillism drawn from millions of distant smudges, the emptiness is not featureless. There are seams and traces, the way soap bubbles merge on a basin of water and leave curved boundaries where films once met. Evidence gathers that what looks like one vast room is the union of several rooms slowly opening into each other. 3, perhaps 4, ancestral hollows that drifted together over eons and became one. Each carried its own slight character, its age, its degree of thinness, and the combined space remembers these differences as variations in shape and in the few lantern galaxies that still glow within. The arrangement of those survivors hints at the old borders. Instead of sprinkling themselves uniformly across the interior, the galaxies cluster into small associations and trace faint lines, as though marking the places where two emptinesses once leaned together. The familiar tube-like chain, 8 brighter beacons, spaced like way stations along an invisible corridor, could be the long scar of a merge, an interface that never fully forgot its origin. Simulations that begin with several smaller underdensities and let them coalesce reproduce such features more naturally than simulations that start with a single enormous hollow. Mergers produce elongation, offsets, and internal filaments that feel right when laid over the maps. The galaxies themselves carry biographies written in their starlight. Spectra reveal how many heavy elements their stars have forged. Colors hint at the age mix: older, redder populations or younger, bluer ones. Across the Boötes interior, these tracers vary in ways that suggest slightly different histories from one side to another. In some analyses, The northern reach seems to host galaxies a shade older and more metal-poor, as if that region's emptiness matured earlier, giving less fuel and less time for repeated star-making and enrichment. The southern side, by contrast, reads as a touch younger, a little more chemically seasoned. Not sharp boundaries, more like gradients on a dusk horizon, yet enough to support the view that multiple hollows met and blended here, each contributing its own tempo. Merging changes not only the interior but also the pace at which the whole clearing opens. When smaller voids combine, the effective repulsion, really the absence of pull, adds up. Matter has more reason to drift outward along the easy lanes, and the edges of the merged region feel a stronger nudge. Over long spans, that means the big room grows faster than any one of its parents would have alone. In a universe where dark energy becomes more influential with time, this tendency intensifies. Small clears become large ones. Courtyards join into plazas. The Boötes example looks less like an outlier and more like a rehearsal for the far future, when the web's bright strands will still exist, but the spaces between them will be broader, calmer, and more common. This view also softens the odds. A single void of Boötes size emerging from random early ripples may be improbably rare. Several smaller ones, forming and then sliding together, is less so. The path from likely beginnings to an impressive present becomes a sequence of modest steps instead of one extraordinary leap. Deep radio surveys add texture to that story. Within the clearing, the handful of galaxies often show radio emission that has the flavor of interrupted lives, episodes of activity and quiescence that could reflect changes in environment as old walls drew nearer, merged, and settled. Gas supplies waxed and waned. Magnetic fields were stretched and relaxed. Star formation flickered accordingly. Scars, perhaps, but the sort that come from long walks, not from falls. Turn again to the oldest light and let it guide the imagination back through the room. A photon leaves the dense lace of a wall, enters the hollow, and the gravitational landscape beneath its feet begins to change while it is still crossing. The hollow slowly shallows. By the time the photon climbs out, the slope is a little different than when it went down. That difference subtracts a sliver of energy. No drama, only arithmetic that plays out over hundreds of millions of light years. Stack such photons by the millions, and a map appears, a gentle blue dip against the general beige of the microwave sky. The imprint is fragile enough that foregrounds dust, gas, the quiet glow of faraway radio sources can blur it, which is why the observed coolness looks modest, like a breath on a mirror. Modest, and yet unmistakably shaped. All of this, the cold imprint, the internal seams, the way merged hollows evolve threads back into the larger tapestry of how structure grows. The web is not only clusters and filaments, it is also the rooms between them, each with a history. Early inflation set the first sketch in faint pencil. Gravity darkened the strands and invited matter toward the crossings. Expansion kept a steady pull on the opposite thread, relaxing the lows and helping their emptiness spread. Dark matter provided invisible skeleton. Gas and dust draped the bones and built stars where the footing was good. In the Boötes region, the scaffolding was sparse, the footing uncertain. The few galaxies that did arise have lived slow, with little traffic and few exchanges, their chemistry modest, their profiles calm. There is a soft lesson in how these absences speak. They do not shout against the bright parts of the universe, they frame them. The cold patch in the microwave background is not a flaw in the baby picture. It is handwriting in the margin, Here the page was thin that helps us read the rest. The merged hollows are not holes punched in the fabric. They are the spaces the fabric needs to fold and drape. Even the puzzling mismatch between simple predictions and measured coolness is a kindness, a reminder that the cosmos invites us to refine rather than to finish. From another vantage, the Boötes clearing is a kind of contemplative chamber built into the house of the universe. The walls, the bright filaments, crowded with galaxies, hum with business and exchange. Inside, the air is wide and the steps echo. A few lanterns burn in the long aisle, steady and unhurried. The earliest light arrives at our door slightly cooled by the crossing, carrying news of a room that has been opening for most of time. Maps trace its outline. Spectra tell us how the few residents live. Simulations practice the choreography of bubbles merging and borders fading. Every new survey adds a stitch, every discrepancy, a place to rest the hand and think. If the far future favors broad, quiet spaces, Boötes is a preview seen at twilight. Not an omen, simply a possibility written into the same equations that give us crowded clusters and blazing star factories. Where density gathers, the universe plays fortissimo. Where it thins, the music leans into rests. The cosmic microwave background holds the whole score at once, ancient and persistent. In that score, the Boötes Colden note is small, but it is played with feeling. From that cooled note in the ancient light, another question drifts gently into view. If the emptiness can leave such a clear fingerprint on the sky's oldest glow, what quiet hand is shaping it now? The conversation turns to the softest actor in the cosmic cast, dark energy, a presence that seems to fill space with a steady pressure, widening distances with a patience that never tires. Most of what exists belongs to this hush. Roughly 2/3 of the universe is written in its ink, and yet it remains almost entirely an inference, a name we give to the tendency of space to accelerate as it stretches. We don't bottle it or weigh it. We notice its work on the grandest scales, the way one notices a breeze by watching leaves. Places heavy with matter muddle that breeze. Galaxies, clusters, and their dark matter scaffolding bend space so strongly that the subtle push of dark energy is hard to hear. A void, by contrast, is a quiet room in a noisy house, with fewer masses to tug and twist. The background pressure stands out. In the Boötes clearing, measurements suggest that space dilates a shade faster than average, as if the hush has just a little more room to speak. It's tempting to imagine dark energy as something like a mist that shows itself best where the air is still. The simplest picture, the one that fits much of what we see, says this mist is uniform, the same everywhere and everywhen. Yet theory, curious by nature, sketches alternatives in the margin. Perhaps the strength of the pressure varies with environment, growing more influential where matter thins. Under names like quintessence, these sketches explore a dark energy that ripples or rolls, faintly responsive to the landscape it fills. If that's even partly true, a place like Boötes becomes a kind of open-air laboratory. Watch the edges of the clearing across cosmic time. Trace how fast its boundary eases outward. Measure the peculiar motions of galaxies near the rim as they lean away from the interior. Those movements, read together, whisper about dark energy's equation of state, a gentle technical phrase that tells how pressure and energy dance within this field. If the pressure is exactly and forever the same fraction of its energy, the universe follows one rhythm. If it varies, the tempo changes. The cooled patch in the microwave background along the void's line of sight fits the mood of enhanced outward flow, a long-term toll that light pays while crossing a region whose gravitational low has been relaxing. The signal is subtle, softened by foregrounds and the small weather of the intergalactic medium, but it carries the right kind of story. Emptiness, assisting the very process that keeps it spacious. A feedback between how little is there and how easily the little becomes less. From that angle, an old riddle looks a touch less sharp. Why does dark energy dominate now, rather than long ago or far ahead? The coincidence problem, as cosmologists call it, asks why the density of this pressure seems tuned to show its hand in our era. If the influence of dark energy leans on environment even slightly, then the growth of broad clears could naturally amplify its role at late times. Not a solution, but a softening. In a universe that is gradually learning to prefer empty rooms, a pressure that works best in empty rooms will feel more present. Boötes, then, offers not an answer so much as a way to ask the question where the signal is cleanest. There is another, older thread to tug. Some models imagine that what we call dark energy is a long echo of the inflaton field, the entity that drove the very first furious swelling of space. If so, vast hollows might preserve faint signatures of that youth, slight preferences in how the pressure behaves when matter is scarce, echoes too weak to notice, near clusters, but audible in the quiet. Looking for such traces is less like hunting and more like listening. Future surveys will map the peculiar velocities around void rims with finer ears, track boundary shapes with better gridded light, and compare those patterns to the many rhymes theory has written down. Step outward from the concept of pressure and feel the geometry at the border. Gravity's usual habit is to gather. Matter rolls downhill toward deeper wells. Filaments feed clusters. Small systems fall into larger ones. Near a great hollow, the landscape is different. The well is shallow, the slope barely there. Beyond the rim, the terrain descends more steeply into the rich districts. Matter tends to flow that way, leaving the hollow even quieter than before. To a traveler moving along the wall, the effect resembles a gentle push from the empty center, a repulsion in the language of flows. Not a new force, but the absence of a pull. Over long times, that current sharpens the boundary and helps the clearing keep its shape. Galaxies along those margins carry the motion in their speeds. Against the grand expansion that lifts all distances, they carry extra drift, peculiar velocities that lean outward faster than a naive average would predict. Closer to the interior, the lean tends to grow. Farther out, it softens into normal web traffic. Simulations draw this behavior with fair fidelity. Place a hollow in a cosmic web, and matter streams around it, not into it, tightening the bright curtains while the center opens. A galaxy that wanders too far inside tends to find its path arcing back toward denser country, like a leaf caught briefly in an eddy before rejoining the river. The survivors we see within quiet, metal poor, with restrained star formation read as relics of an earlier time, systems that lit their lamps before the currents strengthened and have been living on careful rations ever since. Because dark matter provides the invisible bones on which luminous structure hangs, its scarcity multiplies the effect. Without much of that skeleton inside the hollow, gas lacks footholds to pool and cool, and future generations of stars arrive more sparsely. The emptiness doesn't stop at a crisp line. A gravitational shadow spreads beyond the visible border, a zone where the appetite for forming new galaxies is dulled compared to equivalent places elsewhere. In some maps, that quieter appetite extends tens of millions of light years beyond the rim, as if the mood of the hollow diffuses into the neighborhood. The temperature of the thin gas that threads these outskirts carries another small surprise. One might expect infalling gas to warm as it accelerates, crashing and shocking against denser walls. Observations in some directions suggest cooler than expected filaments near the void's edge, a hint that the flow is more laminar than violent, or that the energy budget is being spent in gentle work, stretching and expansion rather than in heat. In the language of bedtime, it's as if the air at the doorway feels cooler than the hall, a draft from the wide room within. Even high-energy travelers, cosmic rays launched by distant supernovae, or the neighborhoods of black holes seem to respect the boundary's mood. Their paths curve through the weak magnetic fields of intergalactic space, and in a geometry like Boötes, those curves can steer them away from the center. The result, when enough of them are counted, is a faint deficit, a shadow in rival directions that mirrors the hollow's position on the sky. It's a delicate effect, easily blurred by all the other weather of space, yet one more way in which emptiness is not absence but character. Threads of philosophy sometimes arrive wrapped as equations. There are physicists who wonder whether gravity itself might write a slightly different grammar in the widest, emptiest halls. General relativity has earned its trust across a century of precise tests, from the dance of planets to the whispers of gravitational waves. Yet the combination of vast scales and deep underdensities is a place where alternatives can be tasted without contradiction elsewhere. Modified gravity theories propose tiny changes in how curvature and energy talk to one another. Changes so modest that only in voids would they leave a mark. Boötes, then, becomes a proving ground. Trace the lensing signal across the rim, weigh the outward flows in detail, map the faint shear it imprints on background galaxies, and compare line by line with both Einstein's stanza and the newer variations. Most likely, the old poem holds. If it doesn't, the difference will feel like the subtlest syncopation, heard only where the room is quiet enough. Meanwhile, the laboratory keeps running, unattended and flawless. Space within the clearing lengthens, the walls gather and brighten. The few interior lanterns turn with composed restraint. New instruments will watch this happening with finer sensitivity. Telescopes that can measure tiny shape distortions of background galaxies to catch the weak lensing of the walls. Spectrographs that can read the small extra redshifts of galaxies skirting the rim. Radio arrays that can trace the whisper of neutral hydrogen as it threads the outskirts, cool and diffuse. From those readings, the pressure's character will come into better focus. If dark energy is truly constant, the void's growth will march to a particular beat. If it varies with place or time, the beat will swing slightly here, slightly there, in ways that careful listening can record. The larger stakes don't intrude on the night. They sit quietly in the corner, waiting their turn. What happens to a universe that leans more and more into wide rooms? The web will remain, but the distances between the bright knots will stretch until the knots feel like neighbors, only by memory. A place like Boötes hints at that mood without demanding it. A preview performed in a small theater, the lines delivered in whispers. If the pressure that opens space is merely steady, the future is long and sparse. If the pressure strengthens where matter thins, the sparsity will deepen more quickly. Either way, the lesson near the rim is the same: gravity gathers, expansion loosens, and between their patient arguments, structure emerges, streets and courtyards, clusters and clears. Stand at that rim in imagination and listen. The bright walls hum with exchange. Inside, time feels a fraction lighter. The old afterglow carries a cooled impression of the crossing. The galaxies along the edge bear small tilts in their motion. The gas is cooler than the mind first expects. Even the most energetic messengers bend away as if honoring the quiet. No alarms sound. The physics remains law-abiding. What feels like repulsion is simply the arithmetic of a universe that prefers to let matter roll toward more matter, leaving the hollows to widen by default. In that soft arithmetic, a void becomes a teacher. It shows how little it takes, just patience and space, for a room to become itself. And it offers to anyone awake in the dark a calm reminder. Not everything that shapes the world does so by pushing. Some things shape it by leaving room. Follow the bright threads outward from the rim, and the pattern of the universe comes into focus the way frost reveals the grain of a window pane. Long filaments stitch clusters to clusters. Intersections glow like little town squares. Between them lie ordinary clearings, where the light thins, but the fabric still holds. On most maps, this network looks continuous, a lace thrown wide across the sky. Then your finger reaches Boötes and slides into open air. No crossing threads, no faint bridges, only a yawning gap in the weave, an absence so complete it feels like a missing note in a familiar melody. That gap is more than scenic. The web is how structure forms and feeds. Dark matter gathers first, invisible and sure, and baryons, the gas and dust that will become stars, settle onto its scaffolding. Galaxies ignite where filaments meet. Clusters are fed by rivers of matter that run along those strands. When a whole section of lace is torn, the routines fail. Filaments that ought to connect to the far side arrive at the brink and simply stop. Clusters near the edge lose their natural avenues of supply and trade, stranded like islands when the causeway breaks at low tide. In the broad neighborhood around the hollow, the birth rate of new galaxies wanes. Without the quiet gravity of dark matter bridges, gas has fewer places to pool and cool. A wide belt of sterility appears, not harsh, just a long silence where there might have been conversation. The flow of matter adapts in ways cartographers of the night can trace. In healthy districts of the web, mass streams along the strands toward the hubs. Infall keeps the hubs bright and busy. The Boötes clearing interrupts those migrations. Streams approach slow and curl along the boundary instead of cutting across. At the line where the lace ends, matter piles up in walls, not because something pushes from within, but because the roads are rerouted. Over time, those margins grow dense and elaborate, while the interior remains spare, a geological basin in reverse, a place that collects space rather than substance. This story is old enough to be written into the universe's first photograph. The ancient microwave afterglow carries tiny temperature shadings that mark where the primordial soup was a whisper, thicker or thinner. In the direction of Boötes, the pattern shows a deficit. The seeds that should have grown into filaments and nodes are faint or missing. It is as though the loom skipped a pass that morning, leaving an opening that later ages could only widen. Some theorists imagine that inflation, the brief, astonishing swell at the beginning, may have unfurled with slightly different tempo here and there, leaving domain boundaries where regions with subtly mismatched properties touch. Whether or not that language holds, the effect on the present is clear. The web cannot fully join across this space, and the two sides exchange less than they otherwise would. Gravity's news still travels, space-time remains one, but the gradients are shallow, the calls across the gap fewer and farther between. Topologists, who love the bones of shapes, would say the network's connectivity has been altered over nearly 1 billion light-years of extent. In plainer speech, the map's grammar changes. Close by, you can trace the consequences in individual galaxies. Farther out, you find the influence disguised as gentle statistical tilts. Fewer small systems per cubic volume, slightly thinner filaments, clusters with quieter outskirts. It is a large defect in a larger beauty, like a missing panel in stained glass that lets more light through. All of this returns, inevitably, to dark matter, the hidden mass that dominates the ledger, yet declines to shine. Most of our confidence in its existence comes from how well it explains the web's shape and the motions of galaxies on almost every scale. The usual picture paints it as a broadly smooth medium that condenses into threads and knots under gravity's hand. In that picture, even the emptiest corridors of the web should keep a modest residue of dark matter, a skeletal clarity rather than a bare void. But Boötes reads as an extreme exception. Weak lensing maps those delicate measurements of how background galaxies are sheared and stretched by foreground mass, suggest a dark matter density in the interior that is only a small fraction of the cosmic average. One of the starkest deficits measured, a skeletal absence where even bone was expected. That absence deepens the riddle of the survivor galaxies. By the standard recipe, stars gather in the deep bowls that dark matter digs. With shallow bowls, the gas splashes out. With no bowls, nothing pools at all. And yet, a handful of small, quiet systems exist inside, their disks turning, their few new stars flickering. Their rotation curves how fast they spin, at different radii, often hint at less dark matter than cousins of similar size elsewhere, as if the same subtraction that thinned the medium also reached into their halos. Simulations, faithful but puzzled, struggled to produce such a combination. Under densities this extreme, galaxies this ordinary. If the code is right and the initial conditions fair, something in the assumptions may need softening. One path of speculation changes the character of the invisible. If the dark component were warmer particles with a bit more kinetic eagerness, it would smudge out small-scale structure, especially in places already starved of gravity's pull. Warm dark matter can leave filaments more fragile and voids cleaner. Another path lets the dark sector talk to itself. Self-interactions, so rare we haven't trapped them yet, but strong enough that, at very low densities, dark matter can scatter out or drift on longer timescales than we expect, hollowing the hollows even further. A third path redraws gravity's law in the quiet, modified dynamics that mimic dark matter where the night is thin, altering how force fades with distance and how orbits hold together. The old poem of general relativity has withstood a century of recitals, and it likely sings true here as well. Still, the quietest halls are where faint harmonies are easiest to test. Light, again, is the adjudicator. The reduced lensing through the interior biases our mass estimates of background structures if we don't account for it, making far objects seem lighter than they are. The galaxies that live within betray their environment, not only in their spins, but in their chemistry and star formation histories. Fewer heavy elements than comparable systems elsewhere, fewer signatures of past mergers, more signs of gas being lost softly to the surrounding emptiness. Each small clue is a fiber. Braided together, they make a cord strong enough to pull new theory toward them. Around the emptiness, matter doesn't simply detour, it flows in rivers. Follow one, and you can walk halfway across the sky without stepping out of its current. The Perseus-Pisces chain, the great arcing parade of galaxies in the north, bends around the Boötes Gap, like a river braided by a promontory, its thousands of members keeping time as if guided by a shared metronome. Other streams curve along different flanks, each carrying groups and clusters toward richer basins. These currents are not gusts, they are long-lived, established by the shape of the gravitational potential and sustained for billions of years. Once a route is carved, the universe uses it. Where streams meet, deltas form. Along certain stretches of the void's edge, multiple currents converge, and the result is a blooming of density, thick walls, bustling superclusters, the sense of a shoreline, bright with towns. Elsewhere, where only a single stream passes, the coast is sparser. The pattern of who gathers where makes a readable map of the underlying pull, including the distribution of dark matter that we cannot see directly. Velocity surveys trace these flows by measuring tiny shifts in galaxy spectra, the extra motion on top of cosmic expansion. The coherence is astonishing. Many thousands of systems, across hundreds of millions of light years, all leaning the same way, by amounts too large to be chalked up to chance, too orderly to be mere noise. Travelers in the currents are changed by the journey. As a galaxy rides a stream, it moves through the thin gas that threads intergalactic space and feels a steady pressure against its own halo of gas. The outer layers can be pared away, star formation ebbs in the outskirts, and the shape grows a little leaner. Encounters are more common along a well-trafficked route. Tides from near passes can stretch one partner, twist another, wake bars in disks, and trigger asymmetric bursts of newborn stars. A quiet dynamism, more drift than collision, but cumulative as seasons. In the temperature maps of the microwave background, there are hints of these grand motions as well. Directional nudges in frequency where large swaths of matter move as one. The light slightly blue-shifted in the approach and red-shifted as it recedes, an ancient barometer for present winds. The void's influence runs beyond what the eye can easily reconcile with the shape of its core. Streams bend not once but repeatedly, their paths recording past epochs when the hollow was smaller, then larger still. Fit those curves with models, and you can read a history of growth written in the waterlines, a chronicle of how the gravitational basin deepened in reverse, less a bowl than a gently rising plane that carries travelers outward. Lay the flow map atop the weak lensing map, and a fuller skeleton appears. Dark matter follows the same general roads as luminous matter, but shows its own preferences in detail, sometimes choosing a slightly different lane, sometimes lingering where light has already moved on. Those differences are not contradictions, they are character, windows into the microphysics of whatever the dark majority is. Beyond Boötes, similar currents interlace across the cosmic atlas, connecting one supercluster to another, one void to the next, like trade winds between islands. The Boötes clearing is not isolated in spirit. It is a large bend in a global circulation. To trace these rivers is to sketch the future in pencil. Matter will continue to stream toward the great basins. The walls along the hollow will thicken and age. The interior will grow quieter, still not absolute, but more spacious. In time, the long-distance traffic between far shores will thin as expansion stretches the sea. The nearest harbors will remain busy. The far ones will pass beyond each other's horizon. The map will not freeze. It will breathe more slowly. It is tempting to call all this a failure of the web, as if the universe had neglected its knitting. Another reading is kinder, and no less true. The pattern includes its rests. Some strands don't meet, some squares remain open, And through those openings, the scale of the whole becomes visible. The lessons are practical about dark matter's temperament, about gravity's grammar in the quiet, about how flows carry history, and they are reassuring in their way. Even where the lace seems torn, the larger cloth holds. The bright avenues know their routes, the rivers keep to their banks, and the emptiness, vast as it is, serves the shape by letting it be seen. If the rivers of matter trace where the universe has been, the deep clearings hint at where it is going. Stretch the calendar forward in your mind, not by years or centuries, but by oceans of time, and the web thins between its bright knots. Dark energy keeps its quiet pressure, and distances lengthen with a patience that does not tire. What the Boötes clearing shows in one neighborhood becomes, little by little, the temperament of the whole. Galaxies that once shared tides and traded gas drift beyond each other's horizons until each lives mostly on memory and what it already carries. Inside the hollow, that mood is already present. The few resident systems red like elders, stars skew red, the nurseries subdued, the gas pantry carefully rationed. With few encounters to jostle clouds into collapse, with no incoming streams to refill the shelves, the pace of birth settles into an occasional ember instead of a blaze. Across distances so great that even a lifetime of light cannot cross them, any imagination raised under such a sky would look out and see only its own porch lamp and the darkness beyond. The lesson feels philosophical as much as physical. Knowledge draws its shape from the number of clues the night provides. In a room with one lantern, you learn the table and the chair. In a house with many windows, you learn the street, the hill, the constellation above the roofline. Even so, a faint thread of evidence would remain. The ancient afterglow, the microwave hush from the universe's first clear morning, would still wash across such a sky, though cooler and thinner with time. Without a parade of other galaxies for context, interpreting that whisper would be harder. Expansion would be felt as a local patience rather than a global story. The sciences that bloom in crowded neighborhoods, measuring flows between clusters, mapping filaments, comparing like with like over grand distances, would have to find humbler tools. Philosophy might tilt toward solitude. Cosmology might be a poem written by one town about its own lamp. Temperature in the hollow tends toward the universe's long habit, cool, then cooler. Where matter is scarce, there are fewer gravitational scuffles to heat the thin gas. Over immense spans, energy spreads and settles. Entropy, the bookkeeper of possibilities, adds its quiet sums. A room that has given up its gradients is not tragic, it is finished with striving. Some theories sketch curiosities on the horizon of ages, protons that, given absurd lengths of time, may decay, particles that fade on calendars no one owns. Isolation could be a kind of shelter in that far arithmetic, but such speculations belong to the most distant shelves. Nearer at hand, the void offers a gently practical service. It lets us measure the universe by listening to emptiness itself. Most ways of gauging expansion lean on light from busy places, supernovae that flare and fade with clockwork, galaxies whose standard patterns help set distances, the corrugation of the web imprinted in how galaxies cluster. A hollow allows a different approach. Because mass is scarce, the tug-of-war between gravity and expansion is unmasked. Watch the shape of the boundary. Read the extra lean in the motions of galaxies skimming the rim. Compare the angular size of the clearing as seen at different cosmic times. These are quiet rulers, but they are clean ones. They tell us that the roomy interior grows a little faster than the average sea around it, an effective order 10% in the language of models, and that difference speaks to the character of the pressure that opens space. Light from the few interior lanterns carries the same message. Their redshifts, the stretching of their spectra by the expansion they endure, come in a touch higher than a simple distance would suggest, the signature of a crossing through an underdense geometry. Stack enough careful measurements, and the pattern emerges from noise. Underdensity and acceleration make companions, and the local flavor of expansion can differ, slightly but meaningfully, from the global broth. Fold these readings into the larger ledger, those from supernovae, from the ripples in the early light, from the graceful wobble of baryon acoustic features, and the uncertainties on the universe's vital signs tighten. Where different techniques have disagreed, the hollow offers another angle from which to triangulate, a way to check if the tension lies in the instruments, the methods, or the model itself. There is housekeeping in this, too. Distances measured through or near the clearing can be biased if we ignore the room's personality. Lensing is weaker, flows are different, and the usual shortcuts need gentle correction. Once corrected, background masses look a shade heavier than a naive reading would give. Supernova yardsticks gain or lose a millimeter, depending on the path their light took. The map becomes more honest by the smallest of amounts. Accuracy, like sleep, is made of many small kindnesses. Across the interior, expansion is not perfectly uniform. Patches that are ever so slightly denser, seams from old merged hollows, regions nearer a thick wall, all evolve with their own quiet tempos. Spectra and positions taken over long intervals let cosmologists sketch these differences, not because they are dramatic, but because they are telling. A part of the void that began emptier will relax faster. A fringe closer to a massive sheet will linger, held just a touch by its neighbor's gravity. Small variations in rate become clues to ancestry. The way growth rings in a tree whisper about old seasons of rain and drought. Simulations tune themselves against this embroidery, adjusting dark energy's assumed stiffness, the ratio of its pressure to its energy, until the modeled room expands the way the real one does. Seen in this light, the Boötes clearing is less an omen than a yardstick laid a long time. It suggests that if the universe continues its long exhale, the ordinary will drift toward the void's aesthetic. Fewer crossings, slower trades, more space between the lamps. The nearby future keeps its bustling districts. The far future lets quiet take larger rooms. What dark energy is steady as a metronome, or slightly changeful like a living tide, shapes how fast that change of mood arrives. The hollow helps separate those tunes by emphasizing the soft parts most other venues drown. There's a kindness, too, in how the void clarifies relationships that are tangled elsewhere. In crowded sectors, gravity, radiation, magnetic fields, and feedback from stars and black holes compose a noisy ensemble. In the clearing, fewer instruments play. The line of dark energy's influence can be traced with fewer interruptions. A redshift, a hair larger than expected, a boundary that widens to a rhythm a fraction brisker than the average. A lensing signal diminished, just so each is a note that, together, outlines the theme. When the same theme is heard in the old microwave song, a cooler patch matching what a long, slow climb out of a relaxing hollow would produce, it reassures more than it alarms. Independent lines, same melody. If the mood of the night eventually resembles the interior of Boötes, civilizations that arise late will inherit skies with fewer signposts. Their sciences may be more local, their stories more inward. Yet the universe leaves breadcrumbs even in sparse rooms. The spectrum of starlight, which carries tales of elements built in earlier fires. The faint background glow, which, though quieter, still hints at a beginning. The dynamics within a single galaxy, which can be read for the laws that also hold everywhere else. The emptiness will not hide the rules. It will simply ask that discovery proceed by listening more closely to fewer voices. Meanwhile, in our era, the Hollow's service is precise and gentle. It sets bounds on how stiff or supple the cosmic pressure can be. It shows how underdensity and acceleration share the work of widening distances. It refines the calibration of yardsticks we already trust. As instruments sharpen telescopes that track tiny shape changes in background galaxies, spectrographs that read motions to a few meters per second over cosmological baselines, radio arrays that map the breadth of neutral hydrogen across wide fields. The Boötes laboratory will yield tighter numbers and perhaps small surprises. If the pressure is truly constant, the expansions we measure will line up on a single, simple curve. If it wavers, even a little, the deviations will show first in rooms like this one. The far vista is spacious but not bleak. Picture a coastline at low tide stretching into blue distance, towns gathered on headlands, long reaches of sand between them, the sea unhurried. The web will still offer its avenues and harbors. The spaces will simply take up more of the map. In that arrangement, emptiness is not failure, it is breath. And in the breath, the universe keeps time, not with clamor, but with the soft arithmetic of widening. The Boötes Void is a chapter of that, counting how rooms open, how light records the crossing, how pressure writes with a steady hand. It does not insist on destiny. It holds up a mirror in which the future can be seen, with the lights low, the pace unhurried, and the patterned threads and spaces together quietly, beautifully intact. Silence, when you listen with patience, turns intricate. What first looked like a blank pane in the night begins to show delicate grain threads, too faint for yesterday's eyes, soft glows at the edge of certainty. Instruments that can sit still for days and count light one photon at a time are returning with small confidences from deep inside the Boötes clearing. The emptiness that defined the place hasn't vanished. It has become textured, revealing a few shy details that were always there and only now come into focus. Ultra-deep exposures from orbit and from mountain summits have teased out smudges so gentle they almost refuse to declare themselves. Some are galaxies in the loosest sense, dwarf systems with so few stars that a single bright neighbor could double their population. In these waifs, the distance between one sun and the next can rival the gap between the Sun and Alpha Centauri, a galaxy diluted to its outline. They sit at the threshold between a bound family and a gathering that might drift apart on a long enough wind. That they persist at all in such thin country says the universe can sketch lightly and still make a shape hold. Different ears bring back different stories. Radio maps, tuned to the faintest hiss, find diffuse regions within the clearing that are not points but veils. Emission too spread out to pin on a single source. The physics could be ordinary plasma behaving in an extraordinary environment, or something more esoteric that prefers wide rooms to crowded halls. In the infrared, a warmer murmur appears, dust so faint it hides from visible light, yet warm enough to glow in long wavelengths. It gathers not as blobs, but as threads that run for millions of light years, as if even here the universe cannot resist a little organization. What warms it is not obvious. No nearby star factories, no raging black holes, only the gentle bookkeeping of energy in a place with very few ledgers. Eyes that watch for ripples in space-time have also turned their attention this way. Nothing confirmed, only the quiet promise of a search. But theory suggests that relics from the universe's earliest minutes, primordial black holes, taut strands of topological defect would survive best where encounters are rare. A void is a museum with the lights low. Fragile exhibits last longer on its quiet shelves. X-ray telescopes, meanwhile, report wisps of hot, thin gas over parts of the interior, hundreds of times warmer than the usual intergalactic medium, yet stretched so far apart you could fly a galaxy between atoms. With no obvious furnaces around, the heat reads like a riddle written in a broad hand. On the dark front, the mass, we infer more than see the clearing, invites new experiments. If the particles that make up the hidden majority sometimes nudge one another, however slightly, those nudges might stand out where ordinary matter is scarce and backgrounds are tame. A void offers a natural, clean room for such work. Fewer false positives, clearer baselines, a chance to catch whispers that busy regions drown. Neutrino observatories listen as well, because the most reticent messengers may gossip with sectors of physics no one has been formally introduced to yet. A small excess from this direction would be a kind of signature, not of what, but that something unfamiliar is present. Even the highest energy visitors, the cosmic rays, show a modest courtesy to the clearing. Their arrival directions bear subtle tilts, as if the long magnetic threads that guide them tend to bend away from the interior. Some may be deflected by concentrations of invisible mass along the rim. Some may be accelerated by engines we haven't named. The pattern is not dramatic, it is statistically polite. Yet in the language of large numbers, polite patterns deserve attention. Back at the microwave end of the dial, the old afterglow becomes precise enough to register second-order effects from anything that lives in the hollow hot electrons that slightly upscatter the background light. Compact masses that lens it by a whisper, tiny shifts layered atop the larger cool signature already known. Each of these imprints is subtle enough to require patience and restraint. Subtract the Milky Way foregrounds, understand every quirk of the detectors, and only then listen for the difference between almost and almost not. Simulations help by sketching what to search for: failed galaxies that never lit, brown dwarfs wandering in long solitude, even the speculative, dark stars that would shine, if they shine at all, by sipping energy from the dark sector. Whether these sketches survive, contact with data is less important than the act of looking. The search itself pushes technology to steadier hands and quieter instruments. Once you learn to read the negative space, your eyes begin to find it everywhere. The first great clearing became a prompt, and astronomers built catalogs with the same care one uses to press flowers between pages. Hundreds of voids now populate the atlases, each with its own outline and temperament. They come small and round, large and elongated, humble and grand enough to span astonishing fractions of the sky. One in Eridanus stretches close to 2 billion light-years side to side, an emptiness so broad that light launched the day dinosaurs first stirred would only now be crossing it. The variety isn't noise, it's a spectrum of how the universe prefers to arrange its breath. No two hollows tell exactly the same story. In Sculptor, there are signs that star-making has flickered on in a few corners, as if supply lines found a way across and a sparse harvest began. In Capricornus, the smallest citizens' dwarf galaxies seem oddly numerous, hinting that certain recipes favor miniature outcomes when the pantry is bare. Step back and the statistics settle into simple trends that feel reassuringly lawful. The larger a void, the emptier, the rounder, the faster its boundary eases outward. Such scalings offer clean tests for how gravity and expansion choreograph structure when given not much to work with. The emptiness has a network of its own. Between big rooms, there are corridors of merely less tendrils, where galaxy counts dip but do not vanish. Connecting hollow to hollow, the way back roads link quiet towns. This negative lattice complements the bright web, the two together completing the pattern. Threads and interthreads, streets and courtyards, notes and rests, environment matters. Where the larger neighborhood is already rich, voids tend to be smaller and less deep. Where the surroundings are thin, rooms can grow to Boötes-like proportions. That dependence is more than a curiosity. It reveals feedback at the biggest scales. The way flows of matter and the geometry of space encourage each other into familiar shapes. The old afterglow stitches these rooms into the earliest history. Many large voids paint their own small, cool patches across the microwave sky. None as clean as Boötes, but together they form a pattern that can be compared to models line by line. Simulations that populate the universe with a realistic family of hollows reproduce the large-scale maps more faithfully than those that sketch only the bright parts. Voids don't merely sit and wait. They steer traffic, shape walls, and temper the growth of galaxies over domains so large it's hard to hold them in a single thought. A few members of the family are odd enough to make the field grin and sharpen its pencils. There are hints that some hollows rotate in ways almost too slow to notice, turning on timescales that make ages look brief. Others seem to cradle concentrations of dark mass that are denser than their sparse light would suggest, as if emptiness and hidden weight can coexist in the same address. And then there are the nested rooms, smaller, empty pockets inside, larger clears like bubbles within bubbles, a reminder that structure can recur across scales in quiet as well as in clamor. None of these features breaks the rules. They simply ask for more careful versions of them. As surveys deepen and widen, more rooms appear, farther away and therefore younger in the look-back sense. Mapping voids at earlier epochs lets us watch their growth in slow motion. Compare fresh hollows to the seasoned courtyards near us, and test whether the same scalings held when the universe was closer to its bright, busy youth. Space-based observatories will add steadiness. New radio arrays will hear fainter whispers. Better gravitational wave detectors will eavesdrop on relics that choose quiet neighborhoods. Piece by piece, the catalog of emptiness will become as informative as the catalog of light. Through all of this, the mood need not darken. A void is not a failure, but a form. It gives context, sets tempo, and provides room for the melody to breathe. The Boötes clearing happened to be the first room where we learned to listen for what is almost not there, and the habit has changed how we read the house at large. The revelations are gentle, that silence has structure, that scarcity can be measured, that the universe's negative space is as articulate as its bright strokes. In a night built from both, understanding grows by learning to rest one's attention where there is little to see, and noticing that little is still something, and sometimes everything we needed to hear. Comparisons sharpen this kind of seeing. Set many clearings side by side, and patterns begin to emerge. How large they tend to grow, how round they become with age, how quickly their borders relax, how often quiet corridors link one to another. With enough rooms on the map, statistics lean from anecdote toward evidence. and the universe allows closer questions. In that wider, calmer view, the Boötes clearing becomes both singular and typical. Singular in its scale and purity, typical in the way it obeys relationships that echo across the whole family of emptiness. Those relationships reach back to the first flicker of structure. In the earliest instant, the universe is thought to have stretched at a pace that beggars ordinary language, an exponential blooming so brief and so decisive that quantum jitters were pulled from subatomic to cosmic size. Inflation is the name we give that breathless prelude. The tiny ripples it magnified, slight thickenings and thinnings, later became the scaffolding for everything. Clusters along crests, filaments between, and the broad, thin places we now call voids. If that story is right, then the biggest hollows are fossils from that dawn. Their sizes and shapes spelling out which versions of the inflationary script the cosmos actually performed. Count the rooms and measure them, and you begin to test the opening act. Some inflation models favor a narrow range of ripple strengths, others a broader palette. Some imprint more large-scale power, others less. Those differences translate into differing expectations for how many small voids, how many big ones, how spherical they grow, how their boundaries evolve. The mere existence of supervoids, such as Boötes, already rules out parts of the parameter space, sets limits on the energy scale and duration of the early swell, and nudges theory towards scenarios that permit unusually spacious clearings, without breaking everything else we observe. The oldest light carries corroboration. Across the microwave sky, temperature dips in the directions of great hollows line up with what inflation would seed and a later accelerating expansion would enhance. Amplitude and angular size are the numbers cosmologists watch, and they sit close to the ranges simple versions of the theory predict. Even the way polarization should be affected, how the early light's preferred orientations are rotated and modulated as signals cross broad, underdensities, offers a second pathway to test the tale. If inflation also launched primordial gravitational waves, as many models propose, then their faint fingerprints in polarization might be easier to extract, where voids have simplified the foregrounds and shaped the path the waves take to reach us. From there, curiosity walks out to the edge of the map. Some ideas allow inflation to run differently in different neighborhoods, spinning off domains in which the rules tilt by a hair fundamental constants shifted slightly. Fields settled into alternative lows of their potential. Boundaries between such domains would look, in our sky, like huge empty swaths where normal structure has trouble stitching across. Supervoids become, in this thought experiment, the negative spaces that hint at other wings of the same great house. It's a working metaphor, not a verdict, yet it guides specific searches. Look for voids whose statistics or alignments stray from the average in ways that match what a domain boundary would imprint. Examine their expansion rates for signatures of a past with a slightly different pressure-energy dance. Even without such speculative embroidery, voids give leverage on the physics of the inflaton, the field that drove the early surge. The rate at which emptiness grows depends on today's dark energy, and on the spectrum of the ancient ripples, how much power was laid down on different scales. By measuring present-day expansion within and around many hollows, and comparing those rhythms with the sizes and counts of voids across cosmic time, cosmologists trim the list of viable inflaton potentials. Quantum field theory contributes one more shy thread. Vacuum fluctuations during inflation should have jostled not only density, but the vacuum energy itself. If traces of that jostling remain, They may manifest as slight environmental differences in how dark energy behaves, stronger or weaker, by a whisper in the widest rooms. It is a delicate claim, but the only venues quiet enough to examine it are places like Boötes. Statistics can also test the subtle, whether the initial ripples were perfectly Gaussian distributed with the tidy bell curve that the simplest models prefer, or whether they arrived with small skews and kurtoses that point to richer beginnings. Voids are sensitive gauges of such non-Gaussianity. Their shapes, alignments, and mutual spacing respond to deviations from perfect randomness in ways complementary to the bright web's response. If the early universe carried long-range quantum correlations, entanglement stretched to macroscopic separation, some of that patterning could survive most vividly where later evolution has been gentlest. In hollows, correlations fade more slowly. Entanglement, if it ever mattered for structure, would have fewer collisions to erase its delicate tracery. The dream of eternal inflation regions that continue their exponential growth while others cool and settle casts another soft light on the data. In that picture, our observable universe is a bubble in a larger froth, and the marks of bubble boundaries might resemble supervoids or sequences of them, aligned in particular ways or carrying distinctive temperature polarization pairs in the ancient glow. Even gravitational waves, born in that first rush, might be gently focused or defocused by broad underdensities, making detection a touch easier along certain lines of sight. Faint advantages matter when the target is a whisper woven into a hiss. All of this pushes on a deeper unease. Begin with the ripples recorded in the microwave background, evolve them forward with gravity, gas physics, and the observed mix of matter and dark energy, and most simulations produce a universe that looks convincingly like ours, except that they struggle to grow voids as large and as clean as Boötes without straining credulity. Turn the dials to their most permissive positions, and the codes still hesitate at the edge of plausibility. That mismatch is not a failure of imagination. It is a chalk mark, inviting refinement. Perhaps the initial conditions were a little stranger than we assumed. Perhaps processes we file under subgrid, the small physics fed into big codes, matter in the quiet more than we credit. Or perhaps the rules themselves need gentle amendments that reveal themselves only in the widest halls. One family of amendments borrows language from phase transitions. Just as water finds ice under one set of conditions and supercooled liquid under another, the early universe may have passed through changes in state where different patches settled into distinct phases. Along their seams, normal structure formation would falter. The embryo of a void could be laid down, not as absence, but as incompatibility. Another family points to compact objects born early primordial black holes, whose evaporation by Hawking radiation, if it occurred in a dense brood, could have injected energy and momentum into the medium, scrubbing regions clean and launching shells that later relaxed into emptiness. These are not dominant stories everywhere. They are candidates for special places. There are quieter adjustments too. If gravity's behavior shifts by a hair on the very largest scales within limits still allowed by current tests, then the growth of structure could diverge from the standard script in ways that favor broader clears. Modified gravity models tune how curvature responds to energy and pressure. The void population provides a classroom to grade their homework, or the adjustment may live in the dark sector. If dark matter interacts with itself, with a strength that is feeble in crowded places but relevant in deserts, scattering, self-heating, slowly drifting out, then the hollows could end up cleaner than gravity alone would predict. Such interactions might have mattered most when the universe was young and densities higher, leaving long-lived fingerprints in locations that later remained calm. Clues accumulate in chemistry as well. The few galaxies that inhabit wide rooms often show elemental mixes that diverge subtly from their peers in bustling districts. Less heavy seasoning from repeated generations of stars, occasional hints of unusual early enrichment. Those differences can be read as timelines: how quickly gas pooled, how often stars formed and died, whether the environment altered the common pathways of nucleosynthesis. Because void galaxies are fewer and simpler in their interactions, their spectra can preserve conditions that crowded history's blur. Fold those readings into the larger networks, and you glean constraints on the early universe's particle content and on interactions that might have nudged light nuclei into slightly different balances. There are correlations on scales that stretch intuition. Maps comparing void statistics with temperature and polarization patterns in the ancient glow reveal alignments and anti-alignments that reach across vast angles. Standard theory expects some of this, the integrated Sachs-Wolf effect, and related phenomena, but certain data sets hint at coherence larger than comfortable. If those hints persist as instruments quiet further and foregrounds are better tamed, they will tug at models of inflation that assume perfect ergodicity across our cosmic patch, nudging thought toward mechanisms that can sustain gentle order over grander spans. Even the Higgs field, the agent that gives elementary particles their masses, wanders into the conversation. Some speculative sketches imagine that, in rare patches, the Higgs settled into a slightly different minimum of its potential during the early universe. In such domains, particle masses would shift enough to disturb how gas cools and fragments. Structure formation would be dulled not by lack of time, but by altered microphysics. The grand emptiness would then be more than geometry. It would be a region with subtly different rules of matter. This is adventurous territory, but the reason to mention it is clear. Voids are the places where differences, if they exist at all, have the best chance to remain legible. None of these ideas claims the whole sky. Each must negotiate with data that are wonderfully constraining: the smoothness of the microwave background, the distribution of galaxies, the statistics of weak lensing, the abundance of light elements. What the family of voids contributes is leverage orthogonal angles of attack, their sizes and shapes, their expansion rates, their alignments with one another and with bright structure, their effects on the paths of light and on the drift of matter together form a chorus that few theories can fake. Simulations that include a realistic census of emptiness reproduce the universe's large-scale maps more faithfully. Simulations that shy away from emptiness tend to overemphasize the bright, missing how much the negative space choreographs the dance. Across billions of light years, the influence is not localized. A great hollow doesn't merely sit, it redirects currents, thickens some walls while thinning others, slows the rise of small systems in its lee, and accelerates the growth of deltas where streams converge. That breadth hints that the processes which birthed such rooms were themselves broad, global rather than parochial. Whether the origin lies in the exact flavor of inflation, in a phase transition seam, in a soft tweak to gravity, or in a dark sector with a whisper of personality, the consequences ripple widely. In that sense, studying a single void is like holding a seashell to your ear. You hear not only the chamber's own hush, but the ocean it belongs to. As instruments continue to quiet and surveys to widen, the gentle statistics of emptiness will tighten. Void catalogs at higher redshift will show us how young rooms differ from old ones. Polarization maps will catch subtler fingerprints of crossings. Gravitational wave observatories may even find that broad hollows act as mild lenses for ancient ripples, focusing the faintest percussion of the beginning just enough to be heard. With each refinement, the space of viable stories narrows, and the connection between the cosmos's grand architecture and the grammar of fields and particles grows clearer. There is a special kind of peace in that. The same negative spaces that help you fall asleep, pauses between words, breaths between notes, are the ones that let the universe's opening measures be read. Boötes does not demand a single interpretation. It invites careful listening across scales, from quantum whispers to the drift of superclusters. Where the map looks most empty, the physics is not silent. It is articulate in a different register, speaking softly about origins, about the laws that chose this world from among many possible, and about how the largest patterns hold hands with the smallest rules. Further out along that wide corridor, the earliest physics keeps leaving breadcrumb marks, small but insistent. Before clocks and rulers could make sense, before particles and forces had taken their separate seats, the universe behaved like a single, shimmering field of possibilities. Quantum rules weren't a sideshow. They were the stage. Probabilities swelled and overlapped, and what we now call events were more like tendencies, softly weighted. As space ballooned, those tendencies were pulled taut and cooled, turning whispers into contours. Brighter strands where the ripples favored gathering, open rooms where the ripples favored release. A super void is the large print version of that script, a place where an ancient slant survived the long translation from quantum to classical. The math behind that story wears poetic names, squeezed states, vacuum modes, decoherence, and each term simply says that fluctuations were stretched asymmetrically and then frozen into place. Think of a drumhead struck once and let to ring. Some notes grow bold, others fade. Inflation was that strike at a scale beyond any instrument we can build. The imprint remains. Gentle excess here, gentle deficit there. In the Boötes clearing, the deficit is writ so large that even our sleepiest metaphors sit up. Its leisurely expansion, its unusual quiet, its preference for letting matter slip past the door, each may be the long echo of how its patch of vacuum hummed when the whole cosmos could have fit inside a grain of dust. Entanglement creeps in like a faint harmony, a connection that refuses to care about distance. In the hot beginning, quantum correlations were braided across scales and then drawn out to spans that now rival the sky itself. Most of those braids unraveled under the bustle of later times, but in the widest, calmest halls, their tracery could persist as the subtlest preferences. Alignments between far-separated structures, flow patterns that lean the same way across great angles, temperature ripples in the microwave background that seem to know about each other beyond what chance would allow. Read with patience. The ancient light looks like a hologram, not a picture of things, but an encoding of relationships among them, a memory of coherence carried forward through expansion and cooled into pattern. There are models held gently, because this is the frontier where the vacuum itself takes on local character in thin places. Empty doesn't mean identical. Under extreme underdensity, the field that sets the pressure of space may settle into a slightly different poise, changing the way distances widen by a fraction. A small difference builds slowly. Given billions of years, a fraction becomes a fingerprint. In that sense, the void's quickened expansion is not an anomaly. It's a lit candle in a draft-free room, revealing currents you can't otherwise see. Then there's the human habit of naming the strange with metaphors, quantum scars. If the early universe moved from a many-voiced superposition into the single melody we inhabit, it might have left places where the transition hesitated, regions that never accumulated much substance, because their original wave pattern discouraged it. Add, as a whisper, the possibility of tunneling, fields slipping through energy barriers instead of climbing them. One rare event does little. A drizzle spread over unthinkable time can drain a bowl. Whether or not that is the specific story here, the stage on which to test it is a room like Boötes, quiet enough to hear small departures, large enough to show their consequences. Hearing requires instruments, unafraid of the dark. In the near-infrared, Webb has been turning up the faintest embers, toy galaxies with only a handful of stars, scattered associations that are barely bound, orphaned clusters that look like a galaxy's memory. Their stellar populations skew old. Their chemical seasoning is light. They are diaries written in a neat, sparse hand. Giant ground-based telescopes, with mirrors wide as cottages, will soon read those diaries line by line, counting individual red giants, catching the barely there glow of young blue stars in corners, where the gas is still just cool enough to condense. In such readings, we'll learn whether isolation slows not only star birth, but the forging of heavy elements, whether void galaxies grow by sips instead of gulps, whether their histories come in long silences broken by brief, asymmetric bursts. At longer wavelengths, the universe speaks in a single patient syllable, the 21-centimeter line of neutral hydrogen. Arrays that stitch together dishes across continents will draw tomographic maps of that whisper through and around the clearing, revealing whether cold gas hides in filaments too faint for starlight to betray. If those maps show thin threads crisscrossing the room, we will know that even emptiness keeps a skeleton. If they remain mostly bare, the story tilts further toward a room truly starved of bone. Fast radio bursts, those brief, bright hiccups from distant galaxies, offer another probe. Their pulses arrive slightly smeared by the electrons they cross. Many lines of sight through the void, many such pulses, and we can weigh the thin air between. While light does its work, gravity hums. Spaceborne interferometers like LISA will listen for the slow notes of gravitational waves, peering beneath the clamor of galaxy clusters and into neighborhoods where long, low-frequency ripples travel with fewer interruptions. A broad hollow can act as a gentle lens, focusing some wavefronts and softening others. If primordial sources exist, tiny black holes from the earliest times, or the taut, hypothetical strings predicted in some high-energy theories, their signatures may be ever so slightly easier to pick out along paths that cross rooms like this. The difference won't be dramatic. It will be the kind we only trust after years of cross-checks, a confidence built of consistencies. Back on the microwave stage, more precise missions will push past foregrounds toward the statistical floor set by the universe itself. They will look for secondary fingerprints from within the clearing, slight brightening where hot, sparse electrons nudge the ancient photons, delicate distortions where compact masses, perhaps dark, perhaps luminous, bend their trajectories, faint rotations in polarization that map the geometry of the path. Each is subtle. Each becomes readable when stacked across many voids and folded into the chorus of other measurements. Underground, neutrino telescopes will widen their eyes. If the dark sector includes particles that converse more readily with neutrinos than with light, then the emptiest halls are where that gossip has the least competition. A directional excess, even modest, becomes a thread to tug, especially when it lines up with a cold mark in the microwave sky and a gentle anomaly in galaxy flows. Similarly, dark matter searches will start to treat supervoids as control fields. Measure here, measure there, subtract carefully. If self-interactions or slow decays leave traces, the contrast will be sharpest where ordinary matter and radiation are scarce. Computers practice the night before we arrive. Exascale simulations already weave dark matter, gas dynamics, starlight feedback, and magnetic fields into evolving tapestries. The newer ones add bolder threads, self-interacting dark matter with a softness that depends on environment. Scalar fields that mimic a dark energy mood swing in thin places. Even quantum-inspired terms that preserve delicate correlations longer than classical codes do. The goal is not to be clever, it is to be constrained. A model earns trust by reproducing both the bright web and the negative space, the statistics of filaments and the scaling laws of voids, the lensing maps and the microwave fingerprints, the long, coherent streams, and the quieting of star formation along their banks. High-energy eyes in orbit will look for heat where there should be none. If hot gas laces parts of the clearing, X-ray observatories with collecting areas 100 times larger than today's will measure its temperature and metallicity and test whether it was warmed by shocks at the walls, by gentle turbulence in the interior, or by engines we struggle to name, dark decay, perhaps, or relic processes from a younger universe. Precision astrometry will take the smallest of measurements, tiny deflections, in the apparent positions of background galaxies as they drift past the rim and turn them into mass maps, weighing the invisible bones of the wall, estimating how much dark matter lingered inside and how much fled. Catalogs of emptiness will swell by orders of magnitude. Millions of rooms, each with its size, shape, depth, neighborhood measured, will turn anecdote into demographics. With such numbers, we can slice by redshift to watch emptiness in its youth, compare void families in crowded versus sparse districts, pick out the rare rotating halls, the nested bubbles, the odd ones, whose statistics refuse to sit still. Hierarchies will become clearer, small hollows inside larger ones, like quiet within quiet, a fractal of rest that mirrors the fractal of bustle on the other side of the ledger. Where multiple messengers overlap, confidence hardens. Imagine a line of sight skirting the Boötes rim. Neutral hydrogen maps show a thin, cool tendril. Weak lensing reconstructions outline a dense, gracefully curved wall. Galaxy peculiar velocities lean outward in a coordinated sway. The microwave background dips a little, and its polarization twists by a hair. A neutrino detector logs a mild, steady excess in that direction over many winters. A gravitational wave catalog hints that low-frequency waves are a shade more coherent along the same path. No one of these would settle an argument. All of them together would not shout, but they would sing. Quantum sensing waits in the wings, the most delicate of instruments seeking the faintest of signatures. Networks of optical clocks already keep time so precisely that a change in gravitational potential, the height of a stairstep, can be felt as a shift in tick rate. Spread such clocks across space or align them along a void sightline with absolute calibration and, in principle, you could measure the tiny differences in time's pace between sky patches that sit behind dense walls and those that open onto the clearing. Atomic interferometers, chilled near absolute zero, can detect accelerations unimaginably small. Scaled up, arrays of them might sense minute curvature differences, across a void's edge. These are, perhaps, experiments, sketched with care and skepticism, but the same was once true of the instruments that first traced the web itself. None of this turns the Boötes clearing into a stage for drama. Its virtue is precisely the absence of theatrics. Few actors, simple geometry, long bass lines, and gently exaggerated contrasts, those are the conditions that let quiet physics speak. The 8 or so lantern galaxies keep their slow time. Their light gives us spectra instead of fireworks, rotations instead of collisions, a history of thrift that reads like a meditation on enough. Along the wall, the traffic thickens and threads, a living shoreline where currents meet. Across the interior, the ancient afterglow passes and leaves the faintest cool, like breath on glass. The longer arc bends toward a future in which rooms like this become the rule rather than the exception. Our night still bursts with towns. Their lights will thin. The web's avenues will remain, but the distances between them will widen until the idea of a shared city fades into legend. It is natural to feel a pang at that prospect. Yet there is mercy in the scale. None of this rushes. The age we inhabit is generous with clues, and the craft we practice now measuring with the quiet, learning from the negative space, will become the heirloom knowledge that outlasts the bright, easy markers. Emptiness, it turns out, is not a blank. It is a structure that insists softly, a presence that shapes without shoving. In it we read inflation's early choices, entanglement's long reach, the temperament of dark energy when nothing else speaks, the private habits of dark matter when it is left alone. We test the grammar of gravity and the punctuation of time. We teach our instruments to be calm. We let maps include not only what gleams, but what breathes. Somewhere along the aisle, a small galaxy turns the spare music of old red stars, a few blue accents where gas has found a way to gather, a halo lighter than its cousins elsewhere. It does not know it is a clue. It simply is. The wall beyond hums with the low thunder of many orbits, many tides. Between them, 300 million light-years of air, clear enough that a single photon can cross it without saying hello to anything at all. In that crossing, the photon grows a shade redder. In that red, a number hides, and in that number, patiently collected and compared. A story of beginnings and of what keeps widening the space between things. If the night has taught anything, it is that quiet is not the absence of news. It is the condition that lets the faintest news be heard. The Boötes Void is not an argument against fullness. It is a reminder that fullness needs room. We live in the room and in the fullness, both. And while we do, we can take comfort in how far a soft signal travels and how much of the universe's early music still echoes, low and steady, through the largest quiet we know. And so we leave the great clearing much as we found it, wide, quiet, exact. The Boötes Void keeps its patient work, widening distances by a whisper, storing clues from the first seconds, offering a clean hall where faint physics can be heard. What looked like absence becomes an instrument ruler, lens, archive, teaching us how beginnings were written and how the future slowly unfolds. It is comforting to remember that the same laws cradle both the crowded cities of stars and the long avenues between them. The questions we couldn't finish tonight are gentle companions. They will wait. Let your breath take up the universe's unhurried rhythm, and let your thoughts drift along those spacious lanes. Somewhere, a single photon is still crossing that dark, and there is more than enough time. Rest now.